see. Okay, it's recorded now. So today we will talk about confidence interval. And if you attended lecture, you should know about this concept already. For example, when you want to study about specific population, like what is the average age of UTM undergrad student? Like just imagine this your population, all undergrad UTM student, and you want to find average age. But then you cannot approach every single student in the school, right? So you will have to randomly sample. And let's say this is your sample, maybe about 50 students. And then you compute the average age of this sample. And the average age that you got is called sample mean. And it is denoted by X bar. And this one, because it is computed from a sample, we call it a statistics. Whereas the average age of all UTM undergrad student is denoted by mu. It is the population parameter. Make sure to ask question if you are not sure about any terminology or concept I'm talking about here. So distinguish between the population parameter and a statistics. Statistics is what you calculate from your sample, whereas the population parameter is kind of a truth, because if you have all UTM undergrad students, then there is only one single value for average age of them. Whereas this number, the sample mean, it will change, depends on what kind of samples you have. Let's say you have another sample of 50 students. Here, you might get different average age. Or if you sample these 50 students, even though they are overlap, but then it will still probably give you different average age of these 50 students. So the sample mean, it varies across samples. However, the population parameter is the average of this whole set. So it is kind of like a constant. So the question is, most of the time when we want to learn about population parameter, we cannot approach every single object in our population. So we will have to sample, and then we calculate the sample mean. And then we would want to use this sample mean to estimate this population parameter. We want to use the information we have from our sample to estimate the population parameter. So that's where confidence interval come in. So we have the concept of confidence interval. It would be given by a sample mean plus and minus this one. Okay, let me just write down the notation and I will explain it. Let's see, so you have this divided by this. Okay. This expression you are seeing here, it is a result of central limit theorem that I talked about last week in the video. So we know that the mean, it follows a normal distribution, having the same mean, but then different standard deviation. I posted video to solve exercise for tutorial last week. So yeah, you can check it out. I did video for exercise 3 and exercise 4 because last week I think I went a bit slow for our tutorial. So I did upload 2 videos. The exercise 4, it was about sampling distribution. That's where I talk about the distribution of this random variable. So yeah, this is the formula for you to construct a confidence interval. So you might notice there are a few things here. The first one is this alpha. This one, it has a name for it. I'm trying to recall it for myself. I think it is significance level. This one, and it is equal to 100 minus the confidence level. So what is alpha, this one. So for example, I want you to calculate 90% confidence interval. Then the confidence level equal to 90. And then your significance level will be 100 minus 90, which is 10. Okay, so here your alpha is 10. And then your z will be z, let's see, isn't percent, I forgot percent, sorry. So 10% divided by 2, it will be z at 0.05. And what does this number mean? We talked in last tutorial that if we are given the area, then we can find the z value for it, right? And this z just means that if we have a normal distribution like this, it has a mean at 0. We want to find z such that this area is 0.05. And if we look at the z table here, again, if you don't remember, the z table we have only give value between 0 and specific z. We want 0 here, z here. We want this part to be 0.05, which means that, what is this part? What should this part be equal to? I know that normal distribution is symmetric and everything under the curve adds up to 1. So everything here add up to 0.5. Yes, I see the correct answer. So here, this area should be 0.5. Everything on the right-hand side of 0 minus 0.05, which is 0.45. Which means I have to look at what is the z value that give me this area equal to 0.45. Let's see, 0.45. Where do I see it? So here you will see 0.4495. And here is 0.4505. And 0.45 is right in the middle, right? It's just right in the center of it. And this number corresponding to 1.64, this number is corresponding to 1.65, So our Z would be something in the middle of 1.64 and 1.65. So it would be 1.645. Do you follow at this point? Let me know if you feel lost because it's important concept. So here, this Z at 0.05, it is just, what did I just calculate? I forgot. 1.645. So this is a Z value corresponding to 90% confidence interval. If you have different confidence interval, this Z also change, and you have to find according what is the area you are looking for. So hopefully that makes sense. And this formula here, you should notice that it only works when you know what is the standard deviation of the population. So this one represents for population standard deviation. So if somehow you know what is the population standard deviation, then you can use this formula. What if you don't know the population standard deviation? There's another distribution that you have to use in that case. So this one is when, let me make it clear. This one is known. This one stands for population standard deviation. When this number is known, then you can use this formula. When that number is not known, then we use t distribution. Let's see. So when this one is unknown, you will need to estimate the population mean by the sample mean, but with different formula. It would be x bar plus minus t at alpha divided by 2. And then you will have something n minus 1 here. And here you can use a simple standard deviation. This one is simple standard deviation. Because if you have a simple and you calculated mean, you should be able to figure out a simple standard deviation as well, right? So in case that you don't know the population standard deviation, which is most of the time it is unknown, then you will have to use this t distribution. And again, it's very, very similar to what I just did. 95% confidence interval mean that your confidence level is 90. Then your significance level is 100% minus 90%, which should give you 10%. Okay, then your alpha would be 10%. And then you will have to look at t of 10% divided by 2 at n minus 1, which is t of 0.05, n minus 1. And this n that you see here, it is the sample size. So it really depends on what is the problem. For example, if they give you n is equal to, let's say 12, and they want you to find 90% confidence interval, then you will have to look at t of 0.05 at 12 minus 1. And this number here, 12 minus 1, it has a name for it. It's called degree of freedom. Okay. Then now we want to find what is t at 0.05 with degree of freedom equal to 11. Then you will have to look at the t table, this one. Degree of freedom is 11, so I want this row, and I want t at 0.05, right? So it is the second column, this one. You might find this table is easier to read than Z because it's really self-descriptive, like it tells you everything that you need. So the T, sorry, not the T, the probability you want to find is 1.796. This one would be 1.796. So this is just the example, like how we would find the T and the Z so that we can find confidence interval. And one thing you should keep in mind is that for a large N, if your N is large enough, I think I read it in your textbook is maybe 30 plus or 50. I'm not sure. I will have to read this again to confirm. But either one of these number, then your T value will be approximately equal to your Z value. So for a large enough N, thank you is 30, someone confirmed, I trust you. So if you have a large enough N, then this value can be approximated by this value. And you will find this useful when we do exercise 2. For now, I think I will give you time to think about exercise 1, maybe 5 minutes, and then I will take it up. Yes, exactly. It depends on the experiment. It's just some kind of cutoff so that when we deal with theoretical thing, it is easier, but it really depends on the experiment. I will take this up at 6:35. Let me know if you have any question. This is our last tutorial, so please ask question if you have any. This one? I will upload the note as well. Okay. Is 1.796 degree of freedom? No, it's not degree of freedom. Degree of freedom is this number, n minus 1. N minus 1 is degree of freedom. 1.796 is the value of this t. Yeah. It is just like for which value of t, then the probability that a random variable greater than it is equal to 0.05. If you look at the table, they do shade the area correspondingly for you. Okay, so for this question, which formula you should use? There were two formula provided. Which one should you use for this problem? How do you know you should use the one with Z? Yes, exactly. So here, this one is given population standard deviation. If you know this number, use the one with Z, this one. So what I normally do is I would just summarize what kind of information I have. So here I know that the mean is this one. This one is a simple mean, obviously, because the magazine reported that the mean of its own reader is something. So we have simple mean is 119,155. And then we are also given the population standard deviation, which is 30,000. And here is say that the sample of 80 household, this one. So n equal to 80. So for question 1, we want to find a 90% confidence interval, which means we will need to find z of alpha divided by 2. And here, 90% confidence interval means that alpha is 100 minus 10, minus 90, which is 10%. So we will need to find z of 10% divided by 2, which is z of 0.05. And I think we found it before, 1.645. We found it here. 1.645. Now we just need to plug in the formula. Our 90% confidence interval will be simple mean minus the z value multiplied with standard deviation divided by square root. And on the other side, I will add it. What you have to do next is just put the number in. X bar is this number. The z value we calculated is 1.645. Population standard deviation is just 30,000. And then square root of n here is 80. And then I do the same thing for what is on the right. This one, but this plus. Yep. This one is just pure substitution. It does not involve any thinking at this point. And now what you have to do is put the number in your calculator. And you would get this number. One nine eight five eight three 3. Yeah, I think your upper one, make sure you calculate it right. Yeah, I got it from the Z because I want to find Z such that the area is 0.05 and like is what I did here. It was an example that I first showed you. Let's see. So here, I want to find the area. This one is 0.05, which means this part is 0.45. These are the two closest area. And then 0.45 is right in the middle. So I would have 1.6. And in the middle of 0.4 and 0.5 is 0.45. So I have 1.645. Does it make sense? Why do you need to find the in-between one? Because I want to find this number. I want to find this number such that this area is 0.45, right? And here, I know that if it is 1.64, it is 0.4495. And if it is 0.6, it is 0.4505. But I want 0.45, which is exactly in the middle. So you always minus the z from 0.5. Not sure what you mean, because here I have 1.64 and then I have 1.65. This one is corresponding to 0.4495. This one is corresponding to 0.4505, but I want 0.45 and it is in the middle. That's why I know it is this point. Does it make sense to you now? Okay. So yeah, this is an interval that we got. And this is the important part. Is this interpretation correct? There is 95% chance that the population mean lies between our lower bound and our upper bound. Is it a correct interpretation of the confidence interval? If you don't remember, then I will recall it for you. This is the wrong interpretation. It's very tempting to interpret it this way, but it is incorrect. Because once you have the interval, then the population mean, it either lies in the interval or it is not in the interval. There is no chance in that. For example, if I give you the interval for the temperature today, if I tell you the temperature today range from, let's say, -5 Celsius degree to 5 Celsius degree. And once I give you the interval, either the temperature right now falls into my interval or it does not fall into my interval. It's like it's like the truth. There's not really anything involved with chance here once you have the interval. Does this make sense? Do you have any question? What would the true interpretation be? So there are few actually, but then I think the easiest one is just that we are 95% confident that what mean we are calculating? That the mean income lies between those two numbers, this one and this one. So it's very different. Here we say we are 95% 90% confident, it indicates how strong is our belief about the interval that we have. That is one way to interpret it. The second way is that if you recall what I talked about in the beginning, this is our population, and we randomly sample like this, and we calculate the sample mean. And this 90% means that if we repeat calculating the 90% confidence interval in this way for many samples, then 90% of those confidence interval that we have will capture the true population mean. Which means like you calculate the confidence interval from this sample, calculate the confidence interval from this sample, and from this one, we do that many times, then 90% of these interval will contain the true mean. Yeah, or what you can say is that there is 90% that your future, 90% that the confidence interval constructed by future sample will contain the true population mean. But once you calculated the interval, it is not the matter of probability anymore. Either the mean lie inside the interval or it is not inside the interval. It's just like 0 and 1. There is no percent involved in it. Any question? But yeah, I do think that this kind of interpretation is the easiest for you to kind of copy. Because just need to change this number, like we are 90% confident, we are 95% confident, that the mean of something that is given in the question lies between like lower bound and then upper bound. If you are asked to interpret that. Okay, if you don't have any question, we will look at number 2. So here we want to find 95% confidence interval, which means our alpha will be 100 minus 95, which is 5%. And here you would want to find z at 5% divided by 2, z of 0.025. Which means that I want to find the z here, such that this area is 0.025. So what should this area be? Because I need to figure out what should this area be so that I can use a z table. If I only have this piece of information, I cannot use my z table. Exactly. So you have to take 0.5 minus 0.025, which should give you 0.475. So I want to find the z such that this area is 0.75. Oops. And I will look at the z table for this. 0.475. Here, we have the exact number. So now I will figure out for what z do I get this area is 1.9. And then I look at the column is 0.06, which means the z value here is 1.96. Do you get this? Yes, it's the same thing, the same process I did for question 1. Yeah, because I talk about the one for question 1, I talk about in the beginning. That's why I didn't redo the whole process. Okay, so now I have my Z. I have all information I need, right? So I just construct the interval. It's really tedious because it's just the same formula, but then it might give you points in the final exam because you just need to calculate correctly. So now I substitute in what is X bar and then what is Z. I just calculate 1.96. And then the population standard deviation and then square root of n. And I would do the same thing for upper bound, but I just added. This one here. Okay. And if you calculate correctly, you should get some number like this. Again, the interpretation for this would be, we are 95% confident that the mean income, by this one I mean the population mean, lies between the lower bound and the upper bound. Any question here? What do you do with 1.96? I substitute it into the Z. This one. I multiply them together.
Can I just say instead of typing it, because I think it's just easier.
Yes. Yes.
I'm just confused this bit, like the 119 155 minus 1.96. What do you do with the 196 and the 3,000 over a square root of 80? What do you do with that? Are they added or times? I'm like confused.
Times. I multiply them together.
Because I did that in my calculator. I didn't get the answer. That's why I was confused.
Yeah, it's like this.
Okay. All right. Thanks.
Okay. Any other question? Okay, if not, then I will move to, could we also interpret this chance? No, I just said that is a wrong interpretation. It's the same interpretation as this one. There is 90% that the mean lies in this interval is a wrong interpretation. And the interpretation you just wrote down is the same thing. For future, yes, but not this interval. If you want to use the future one, you would have to say there is 95% chance that the future 95% confidence interval would capture the true population. But then it does not have anything to do with this number. Okay, I will move on to question 2. So we have the name for this term here. When we talk about the confidence interval, we did introduce this notation. this one, and we call this term here the margin error. And this is the question. I will give you maybe 2 minutes to read it, and then we will solve it together. So for this problem, we are given the sample size. So a sample of 25, which means n equal to 25. And then we are given average amount over speed. This one is 11.6 kilometer per hour, which means our sample mean is 11.6. And then this one is the simple standard deviation, because it say that the result was obtained from 25 sampled speed. That's why this standard deviation is a simple standard deviation. So I will write S equal to 8. And then we have the 95% confidence interval. This one we are given from 8.3 to 14.9. So they ask us, what is this quantity? What is this quantity? And remember, for the confidence interval, this is how we obtain the confidence interval, right? So we have x minus the t, and then times s over square root n, and then x plus t times s over square root n. So this was how we construct the confidence interval. In here, it would be 8.3 and 14.9. So how can I find this term? Given that I know what is x bar, how would I find that term? What do you think? I know this one is equal to this. I know this one is equal to this. And I know what is x bar. How can I find this term? Divide. So I have x bar plus t times s over square root n equal to 14.9, right? Which means that t times s square root n equal to, yes, you can do that, 14.9 minus x bar. So here I have 14.9 minus x bar here is 11.6. Then I would get 3.3. Or another way you can do is take x bar minus t s over square root n equal to 8.3. Then t of s over square root n would be 8.3 plus x bar. You can also do this as well. Sorry, not plus, x bar minus. And then you would also have 3.3. So you can do either way. You should still come up with margin of error is 3.3. And then for the second one, you want to reduce this arrow. You want to reduce this one to 2, less than 2, less than or equal to 2. And you will have to find for what values of n you can achieve that. Because in order to reduce the variability, you have to increase n. Increase the sample size. And then you will have to assume that the sample size is large enough. Then your t at 95% confidence interval is t at 0.025 will be equal to z at that point, like this. You have to assume that the n is large enough such that the value of t you have will be equal to this z, which means the margin of error will become 1.96. Actually, let me just write this. Z at 0.025 times s here is 8, and then square root of n, you want it to be less than or equal to 2, and this value is just 1.96. Like this. And then if you calculate it, you will get n is greater than 61 point something. But it is greater than 61, which means that you will have to pick n to be at least 62. Because you want to round up to the nearest integer. Do you mean t of 0.025? Yes, I mean it's t, but then if n is large enough, the t distribution will look like the z distribution. Yes, because we talk about it, right? Like n greater than or equal to 30, then the t distribution will be similar to z distribution. So that's why I substitute it in here. There's the third question as well, but it is very, very similar to what we just did, but with t distribution. So solution will be posted and you can try to solve it and compare the answer. Do you have any other question for me? If not, then it's the end of our tutorial. And good luck with your exam.